Hello everybody. So today our topic is line spectra. Last time we talked about photoelectric effect, how it is formed, and how Einstein came up with the equation of energy that was related to the velocity and your lambda. Now today we are going to talk about line spectra. It's a very interesting phenomena. Let's see what actually it's all about. We all know that our light actually consists of many different colors. If we pass that light through a prism or any glass-like object, we can see that the light is dispersed into its different colors formed, right? But this also explains some properties of photon. Let's see. Let's read this out, and you will come to know that how interesting your line spectra is. We will now look at another phenomena which we can explain in terms of light as photon. We rely a great deal on light to inform us about our surroundings. Using our eyes, we can identify many different colors. Now, if you see that your eye can actually see all the colors, right? We see all the spectrum. So this is the reason they think about that white light can actually split into different spectrums. You will be familiar with the way in which this can be done using a prism. We all know that using a prism or using a diffraction grating, you can actually see different colors splitting from a white light. Okay, and the wavelengths are from 4 into 10 raised to the power minus 7 meter. It's for violet, and to about 7 into 10 raised to the power minus 7 meters for red, as in figure 30.12a. Let's discuss this one. Okay, wait. This is interesting. Okay. Now, let's see all these diagrams. They say that if I am passing my white light through a prism, so I'm going to get, or through a diffraction grating or prism, anyone. So through a diffraction grating, if I'm going to pass my white light, I'm going to get this spectrum. Okay? All these colors. If I'm going to pass my mercury from a diffraction grating, I'm going to get all these colors only. Okay? So it doesn't contain the whole spectrum. If I pass my helium through diffraction grating, I'm going to get all these colors. And if I'm going to pass my cadmium vapors, I'm going to get these colors. Now, by seeing the colors, actually you can predict the chemical. Okay? And it was done before. There was one scientist, let me see, it's mentioned here. Yeah, William. William actually did exactly like this. He used to know about the elements by passing through it like a diffraction grating, and by checking that what wavelengths are actually getting produced, what colors are getting produced, and then he will know that, oh, it is this particular element. So it's a very important thing. Like line spectra, we have never imagined that line spectra can be used for this purpose as well, which is quite interesting. It shows the line spectra of hot gases and the elements mercury, helium, and cadmium. Each element has a spectrum with a unique collection of wavelengths. Okay, so the helium will have different type of wavelengths of colors, whereas the cadmium will have a different wavelengths. So from the wavelengths, you can actually differ which element is there. These line spectra, which shows the composition of light emitted by the hot gases, are called emission light spectra. So what is an emission light spectra? This is the line spectrum that is formed by to see when we are seeing that the composition of light in that particular element. If we want to observe that is your emission line spectra. The spectra that is released or emitted by any hot gas, okay, the colors or wavelengths which a single element is actually releasing out, that is what your emission line spectra is. So emission line spectra, these line spectra which shows the composition of light emitted by a hot gases are called emission line spectra. Okay. Now let's see, there are actually two types of line spectra. One is the emission line spectra, another is the absorption line spectra. Absorption line spectra is also very important, and it is also used to actually know what element is used and to read about different types of phenomena as well. Now, what is the absorption light spectra? We pass a white light actually through that particular diffraction grating, and that particular white light is actually passed through a cool gas first. From that cool gas, that light is passed through the diffraction grating. Some of the wavelengths we will observe is absorbed by these cool gases. Okay, so because of that absorption, now the line spectra will not be like this line spectra. Okay, it won't emit all the wavelengths. Some of the wavelengths are getting absorbed. Okay, so because of this absorption, you will see some black lines in your output. Okay, and it won't be like, this very nice spectra of all the colors. So you will actually observe some black lines in between like this, at different places depending on which cool gas you are actually passing it through. So these black lines are actually representing that these wavelengths are being absorbed. Okay, which is shown here. Oh, it's here. Okay, which is shown here. That these black lines are actually showing that my wavelengths are getting absorbed if I have passed my white light through a cool gas and then through a diffraction grate. Okay, so now you should know the difference between the emission spectra and the absorption spectra. In absorption spectra, you will see that less black lines are there. Okay, like black portion is less and the colored portion is more. Whereas in the emission spectra, just see, black portion is more and the colored portion is less. So you can easily differentiate by just seeing the diagrams. Okay, but you should know the logic as well, that why it is happening. In this one, you are just in the emission spectrum, you are just passing your gas through a diffraction grating and you are observing that which wavelengths that particular gas actually have or element actually have. Okay, so in absorption, you will come to know that what wavelengths your gas is going to absorb from the white light. Okay, so this is the basic difference between your emission spectra and your absorption spectra. Okay, certain wavelengths has been absorbed as the white light passes through the cool gas. Obviously, absorption line spectra are found when the light now this is a very good thing, that when this particular phenomena is observed, if you have seen that star is actually breaking down and that phenomena, you can still see light coming out of it. So it is because of the absorption line. So absorption line spectra are found when the light from the star is analyzed. Okay, the interior of the star is very hot and it emits white light of all wavelengths in the visible range. However, this light has to pass through the cooler outer layer of the star. Okay, so there is some gas around it. Okay, as a result, certain wavelengths are absorbed. Shows the spectra. Okay, down there is one image of, you can see from the book, which shows the spectra for the light. So basically, star should be white in color. Okay, it should be like a white, but when you see, you don't see it like white, which shows that certain wavelengths are actually getting absorbed by the outer layer. Okay, and when we have also seen that when the star is breaking, right, and you see orange or red light only, and the reason is again that because of the gases around the stars, some wavelengths are getting absorbed, and this is making our star to look like of that color. Actually, it is like consist of white color, all the white light. Okay, so this ends the line spectra. Thank you so much.